So in this video, let us discuss about the mirror formula for a concave mirror forming a virtual image. Suppose this is a concave mirror and this point is its center of curvature and this is the principal focus. Let's call this point as the pole P, center of this reflecting surface. That's the pole. Now if you place an object between F and P like this, clearly you have to draw two lines in order to form the image. Suppose if a line or the ray passes parallel to the principal axis, this line through this point C and P is the principal axis. This dotted line is the principal axis. If you draw a line parallel to the principal axis, after reflection it will pass through the focus like this. Clear? And another line, another ray in line with the center of curvature, that is, let me draw again, that is any ray which passes in line with the center of curvature. If it touches the mirror, after reflection it retraces the same path. So it will move like this. Clearly, there is no scope that these two rays will meet on the side of the concave mirror. But you can extend this like this behind the mirror so that these two rays will meet here. So an image is formed here. Clearly, there is no actual meeting of this ray. We just extrapolated and meet it here. So the image formed will always be a virtual image. Now for our convenience, we have to take one more ray. Let me take a ray from the top of the object to this pole. Clearly, at the point P, this ray will get reflected like this. Okay, when you extrapolate that ray also, it will meet at here. Now let's call all these endpoints of this ray. Let's call this point as A, this point as B, and this point as A dash. This A dash B dash is actually the image, the virtual image formed. Now, before coming to derivation, this angle, if I call this as angle I, see this CP is actually passing through the center of curvature. Actually, C is the center of the spherical surface. So this CP will be normal. And we know by the laws of reflection, this angle of incidence is always equal to angle of reflection. So I can mark this point as also, mark this angle as also I. But this I and this one, these are opposite angles, vertically opposite angles. So that also will be I. So for the triangle PAB and PA', this one is actually 90 and the other two angles are also the same. Now let me consider this triangle. Consider the triangle, let's say PAB and triangle PA', PA'. Now that is, let me draw it here again. That is, this point is P, and this one is A, this point is B, this is A dash, this is P dash. That is this triangle. We know these two angles are equal. Also this angle is 90. Now we can, when you consider the similarity of triangles, that is the side opposite to this angle, that is AB, divided by this angle is equal to this angle. So the side opposite to this angle is A dash B dash is equal to, also the third angle will also be equal. If two angles of a triangle are equal, the third angle will also be equal. So the angle opposite to this angle, the side opposite to this angle is AP divided by the this angle is equal to this one, and the side opposite to this angle is A dash B. This is because of the ratio of similarity triangles. Sorry, ratio of similar triangles. Similar triangles. For two similar triangles, the sides opposite to equal angles are always proportional. So let me call this as equation number 1. Now let me take another triangle. Let's say CAB. Consider triangle that is CAB and triangle, let's say CAB and CA dash B dash. That is these two triangles. This one is CAB, this A dash B dash. That is these two triangles. Clearly this angle is common for both these triangles. Also this angle is 90. For the bigger triangle and the smaller triangle, this angle is common. So that the third angle, that is this angle, will also be equal. That's so for then these two triangles also come under similar triangles. So you can write the ratio, that is angle side opposite to this angle is AB divided by, for the big triangle, the side opposite to this angle is A dash B dash is equal to, let me consider these two angles, that the angles I marked on the green color, and side opposite to this angle is CA, or let me write AC, by the side opposite to this angle. You have to consider the whole triangle, okay, CA dash B dash. So the side will be A dash C, that is this one, this length A dash C. Let me call that as equation 2. So when you compare 1 and 2, or both the left hand side are the same. Therefore you can write AP upon A dash B is equal to AC divided by A dash C. Let me call that as equation number 3. Now let us represent the variables such as object distance, image distance, etc. in the figure. We have the distance of the object. This one is the object AB from the pole, that is this length is actually U, the object distance, and the image is formed in here. So the distance of the image from the pole, we call that as V, and this length that is from F to P is the focal length F, and the distance from C to P, we call that as 2F. Actually radius of curvature is double the focal length. We know the radius of curvature, that is CP is the radius of curvature, is actually 2F. Okay. Now we have AP. AP you can write that as AP itself by A dash P. A dash P, you write it as A dash P itself equal to AC. See, AC is this one, this length. So AC will be CP minus AP. Right. So AC is equal to CP minus AP divided by, now A dash C is this whole length. So A dash C will be A dash P plus PC or CP. Clear? This whole length A dash C is equal to A dash P plus PC or CP. Now let me put all these variables in this equation. Remember one thing, all the variables which is on the left of the P is taken as negative, that is on this side it is negative, and all the variables on the right side of P we take that as positive. So that is according to the new Cartesian system. So always remember that before you put the variable, before putting the variable. So AP is on the left hand side, so you have to write minus U by A dash P. A dash P is actually on the right hand side, so you can put V itself. CP on the left hand side, it is actually minus 2F minus AP. Again AP is on the left hand side, so you have to write minus U by A dash P V plus CP is actually minus 2F. Clear? Now you can simplify this equation. So minus U by V is equal to minus 2F, minus of minus will become plus by V minus 2F. Now if you cross multiply, you will get minus U into V minus 2F is equal to V into minus 2F plus U. So this will be minus UV, minus and minus will become plus, plus 2FU is equal to minus 2FV plus UV. Now take UV to one side and minus this term to the left hand side and UV to the right hand side. Then you will get 2FU plus 2FV is equal to UV plus UV. So that you can take this 2F outside, 2F into U plus V is equal to 2UV. You can cancel this 2 and F will be UV divided by U plus V. Taking the reciprocal on both sides, you will have 1 by F is equal to, take the reciprocal on this side also, so U plus V by UV. Now divide each term with UV, you will get 1 by F is equal to U by UV plus V by UV. Cancel this U and cancel this V. So that 1 by F will be 1 by V plus 1 by U. So this is the mirror equation. The mirror equation actually remains the same. It does not depend on whether the image is real or virtual. It always remains the same, but when we are asked to find the mirror equation for a virtual image, you have to use a different context like this. Clear?